welcome to NUM Academy CET Coaching Classes 2020. The beauty of the chemistry is that I can design my own molecular world. Let us start with the subject chemistry and the topic structure of atom from first view. Atoms. What are they and what do they do? This is a question which arises when we hear about the lesson structure of atom. Atom is the smallest indivisible particle of the matter. Atom is made up of electron, proton and neutrons. Particle: electron, proton and neutron. Electron is discovered by Sir J.J. Thomson in the year 1869. Proton is discovered by Goldstein in the year 1886. Neutron is discovered by James Chadwick in the year 1932. The nature of charge of electron is negative. The nature of charge of proton is positive. Nature of charge of neutron is neutral. Amount of charge of electron is 1.6 into 10 power minus 19 coulomb. Amount of charge of proton is 1.6 into 10 power minus 19 coulomb. Amount of charge of neutron is 0. Mass. Mass of electron is 9.11 into 10 power minus 31 kg. Mass of proton is 1.672614 into 10 power minus 27 kg. Mass of neutron is 1.67492 into 10 power minus 27 kg. Subatomic particles. Electron, proton and neutron are the subatomic particles. The symbol of electron is E and proton is P and neutron is N. Approximate relative mass of electron is 1/1836 and proton is 1 and neutron is 1. Mass in kg. The electron's mass in kg is 9.109 into 10 power minus 31, whereas protons 1.673 into 10 power minus 27, whereas neutrons 1.675 into 10 power minus 27. Mass of electron in AMU 5.485 into 10 power minus 4. Of proton 1.007, whereas of neutron 1.008. Charge of electron in coulomb is 1.602 into 10 power minus 19 and of protons is 1.602 into 10 power minus 19, whereas of neutrons it is 0. Actual charge of electron in ESU is 4.8 into 10 power minus 10. Proton 4.8 into 10 power minus 10, whereas of neutron it is 0. There are various atomic models proposed on the theory of atoms. First one, Thomson's atomic model. It is also called as plum-pudding model. Its postulate is atom is a sphere of positive charge in which number of electrons are embedded. The limitation of Thomson's atomic model is it could not satisfactorily explain the results of scattering experiment carried out by Rutherford. Rutherford's model. Postulates. First one, almost all the positive charge and mass of atom is present in its nucleus. Second one, electrons revolve around the nucleus in circular orbits. Third one, there is strong electrostatic attraction between nucleus and electrons. Limitations of Rutherford's model is it could not explain the stability and electronic structure of atom. Important terminology. Terms and its definition. Atomic number denoted by Z. It is defined as number of protons or electrons of neutral atom. Mass number denoted by A. It is defined as total number of protons and neutrons in an atom. Nucleons. It is defined as the protons and neutrons are present in a nucleus. So, these fundamental particles are collectively known as nucleons. Isotopes. Defined as atoms of the element with same atomic number but different mass number. Example, hydrogen with the atomic number 1, mass number 1. Hydrogen with atomic number 1, mass number 2. Hydrogen with atomic number 1, mass number 3. Isobars, defined as atoms having the same mass number but different atomic numbers. Example, phosphorus with atomic number 15, mass number 32. Sulfur with atomic number 16, mass number 32. Isotones, defined as atoms having the same number of neutrons but different number of protons or mass number. Example, carbon with atomic number 6 and mass number 14. Oxygen with atomic number 8 and mass number 16. Nitrogen with atomic number 7, mass number 15. Isoelectronic, defined as atoms, molecules or ions having same number of electrons. Example, N2, CO, Cn-. Nuclear isomers, atoms with the same atomic number and same mass number but with different radioactive properties. Example of nuclear isomers is uranium X, half-life is 1.4 minute, and uranium Z, half-life is 6.7 hours. Isosters, defined as molecules having same number of atoms and also same number of electrons are called as isosters. Example, N2 and CO. Here there is a graphical representation of a wave with a wavelength lambda and amplitude A with a crest and its trough. Terms and its explanation. Wavelength, denoted by lambda, is the distance between two neighboring troughs or crests. Frequency, denoted by mu, is the number of times a wave passes through a given point in a medium in 1 second. Mu is equal to c by lambda. Velocity, denoted by c, is the distance travelled by the wave in 1 second. C is equal to v into lambda. Wave number is the number of wavelengths per centimeter. Wavelength, amplitude, denoted by A, is the height of the crest or depth of the trough. It determines the intensity of the beam of light. Electromagnetic waves, different radiations with their wavelength. Radio waves, it has the wavelength of 3 into 10 power 14 to 3 into 10 power 7 angstrom. Microwaves with a wavelength 3 into 10 power 9 to 3 into 10 power 6 angstrom. Infrared rays with a wavelength 6 into 10 power 6 to 7600 angstrom. Visible with a wavelength of 7600 to 3800 angstrom. Ultraviolet with a wavelength 3800 angstrom to 150 angstrom. X-rays with a wavelength 150 to 0.1 angstrom. Gamma rays with a wavelength 0.1 to 0.01 angstrom. Atomic spectrum of hydrogen atom. 1 by lambda is equal to wave number is equal to RH into 1 by N1 square minus 1 by N2 square, where RH is equal to Rydberg's constant, that is value is 108978 per centimeter. N1 and N2 have integral values as follows. When N1 is equal to 1, it can have the values of N2 is equal to 2, 3, 4 so on in the spectral series Lyman visible in the UV region. For N1 is equal to 2, N2 may have the values of 3, 4, 5 and so on in the spectral line series Balmer visible in the visible region. For N1 is equal to 3, N2 may have the values of 4, 5, 6 and so on in the spectral series Bastian in the spectral region infrared. For N1 is equal to 4, N2 may have the values of 5, 6, 7 and so on in the spectral series bracket in the spectral region infrared. For N1 is equal to 5, N2 may have the values of 6, 7, 8 and so on for the spectral series P fund and the spectral region infrared. Photoelectric effect. First one, its postulates are ejection of electrons takes place from the surface of metal when light of suitable frequency fall on it. Second one, minimum frequency required for ejection of electron is called threshold frequency, denoted by nu naught. Energy of the ejected electron is directly proportional to the frequency of radiation. Fourth one, number of electrons ejected per second depends on the intensity of radiation. The photoelectric equation is h nu minus h nu naught is equal to half mv square. Planck's quantum theory. Substances radiate or absorb energy discontinuously in the form of energy packets. The smallest packet of energy is called quantum. In case of light, the quantum is known as photon. The energy of a quantum is directly proportional to the frequency of the radiation. That is, E is equal to h nu, where nu is the frequency of radiation and h is Planck's constant, having the value 6.626 into 10 power minus 27 erg second or 6.626 into 10 power minus 34 joule second. A body can radiate or absorb energy in whole number multiples of quantum h nu, 2h nu, 3h nu and so on up to nh nu, where n is the positive integer. Planck's quantum theory. Energy is not emitted or absorbed continuously, it is emitted or absorbed in the form of wave packets or quanta. In case of light, the quantum of energy is often called photon. According to Planck's quantum theory, E is equal to h nu, therefore E is equal to hc by lambda. Thus, greater the wavelength of radiation, lower will be the energy. Bohr's atomic model. Electrons revolve around the nucleus in circular orbits of fixed energy. Electrons revolve only in those orbits whose angular momentum mvr is an integral multiple of h by 2 pi. Electron absorbs energy in the form of electromagnetic radiations when it jumps from lower energy level, that is ground state, to higher energy level, that is excited state, and vice versa. Energy absorbed or released in an electric jump is given by dE is equal to E2 minus E1 is equal to h nu. Energy of stationary state of hydrogen atom, that is En, is equal to minus RH into 1 by n square. For an hydrogen-like species, that is He plus Li2 plus with atomic number Z. Radius of nth orbit Rn is equal to 52.9 into n square divided by Z picometer. Energy of nth orbit En is equal to minus 2.18 into 10 power minus 18 into Z square by n square is equal to minus 13.6 into Z square by n square electron volt is equal to 313.6 into Z square by n square kilocalorie per mole. Velocity of electron denoted by V is equal to 2.18 into 10 power 8 Z by n centimeter per second, where n is equal to 1, 2, 3, 4 and so on. Limitations of Bohr's theory. First one, it is failed to explain the spectra of atoms having more than one electron. Second one, it is failed to account for the splitting of spectral line source of a spectrum is placed in a strong magnetic or electric field. Third one, dual nature of particle and the uncertainty principle was ignored in the Bohr's atomic model. De Broglie equation. Lambda is equal to h by mv is equal to h by p. Heisenberg's uncertainty principle. It is impossible to determine simultaneously the exact position and exact momentum of an electron. Delta x into delta v is greater than or equal to h by 4 pi m. Bohr model of the atom. The Bohr model is a planetary model in which negatively charged electrons orbit a positively charged nucleus. A photon is emitted with energy E is equal to h nu. Quantum numbers. Principal quantum number denoted by n. It tells the main shell in which the electron resides and the approximate distance of the electron from the nucleus. Second one, maximum number of electrons a shell can accommodate is 2n square. Azimuthal or angular momentum quantum number denoted by L. It represents the number of subshells present in the main shell. Second one, these subsidiary orbits within a shell will be denoted as S, P, D, F and so on. This tells the shape of the subshells. For a given value of n, there are n possible values of L starting from 0 to n minus 1. The values of L, for the value of L is equal to 0, notation of the subshell is S. For the value of L is equal to 1, notation of the subshell is P. For the value of L is equal to 2, notation of subshell is D. For the value of L is equal to 3, notation of subshell is F. For the value of L is equal to 4, notation of subshell is G. The magnetic quantum number, denoted by M, it determines the number of preferred orientations of the electron present in a subshell. For a given value of L, there are 2L plus possible values of M starting from minus L to plus L. For the value of L is equal to 0, notation of subshell is S and the values of M is 0. For the value of L is equal to 1, notation of subshell is P, values of M is equal to minus 1 to 0, 1. For the value of L is equal to 2, notation of subshell is D, values of M is minus 2, minus 1, 0, 1, 2. For the value of L is equal to 3, notation of subshell is F, values of M are minus 3, minus 2, minus 1, 0, 1, 2, 3. Quantum numbers. There are 4 quantum numbers, that is principal quantum number, angular momentum quantum number, magnetic quantum number and spin magnetic quantum number. For the principal quantum number, the symbol is N and the values is 1, 2, 3 and so on. It determines size and energy level. For hydrogen, energy dependent only on N, that is shell. Angular momentum quantum number, its symbol is L and the values are 0, 1 and so on N minus 1. Determine 3D shape of orbitals. For 0 is equal to S. For the value of L is equal to 1 is equal to P. For the value of L is equal to 2 is equal to D. For the value of L is equal to 3 is equal to F. Subshell's value L is equal to 0, 1, 2, 3 and so on. Magnetic quantum number, symbol M, values minus 1, 1, minus 1, so on, minus L. Special orientation of orbitals. Spin magnetic quantum number, symbol is MS, values plus half or minus half. It gives the spin state of electron. Spin quantum number, S, it determines the direction of spin of electron in an orbit. There are only 2 possible values for spin quantum number, that is minus half or plus half. Rules for filling of electrons in various orbitals. First one, of Bohr principle. Electrons are added one by one to the various orbitals in order of their increasing energy, starting with the orbital of lowest energy. In neutral isolated atom, the lower the value of n plus L for an orbital, lower is its energy. The increasing order of energy of various orbitals is 1s less than 2s less than 2p less than 3s less than 3p less than 4s less than 3d less than 4p less than 5s less than 4d less than 5p less than 6s less than 4f less than 5d and so on. Pauli's exclusion principle. An orbital can contain a maximum number of 2 electrons and these 2 electrons must be of opposite spin. Hund's rule of maximum multiplicity. Electron pairing in p, d and f orbital cannot occur until each orbital of a given subshell contains 1 electron each or is singly occupied. Exceptional configurations. Stability of half-filled and completely filled orbitals. Cu has 29 electrons. Its expected electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d9. But a shift of 1 electron from lower energy 4s orbital to higher energy 3d orbital will make the distribution of electrons symmetrical and hence will impart more stability. Thus, the electronic configuration of Cu is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 and 3d10. Fully filled and half-filled orbitals are more stable. Electronic configuration of chromium is argon 4s2, 3d10. After the shift of electron from 4s to 3d, actual configuration will be of chromium is argon 4s1, 3d5. And electronic configuration of copper argon 4s2, 3d9. After the transfer of electron from 4s to 3d, Its actual configuration is argon 4s1 3d10. Electron promotion accounts for multiple ionization states Fe+2, Fe+3, so on. Thank you.